So ladies and gentlemen, on this first part, all it's asking is it growth or decay. So number one, that is growth. Why? Because the base is greater than 1. The a value is -1, but the base itself is greater than 1. The base is actually 2. The a value is -1. All that does is cause it to be a growth in a negative direction. It gets reflected over the x-axis. Number two, that is also, that one's a decay. It's not growth, it's decay, because 2/3 is less than 1. This next one, it looks like a decay because you might be thinking that your base is less than 1, but it's not a decay, it's actually a growth. Why is it a growth? Well, if you notice, the exponent is negative. And remember, when you have a negative exponent, you need to flip the fraction and it becomes positive. You guys remember that? So this actually becomes this with the 8 in the front. Now the 8 is just the a value, it doesn't really matter. But if you look at the inside of the parentheses here, this base is really greater than 1, it's 2. So this is actually a growth, not a decay. Looking at this one, if you don't remember when we covered irrational numbers, e is an irrational number, kind of like pi. Pi is 3.14 and it's a decimal that continues forever. E is the decimal 2.72 and it continues forever. So because your base is 2.72, it's greater than 1, that's also a growth. Now this one right here, same thing, the negative sign means that you're going to have to flip the e and make it 1 over e. So that's really 1 over 2.72, which means that it's a decay function because the base is less than 1. Let's actually get to some graphing ones. I'm not going to do all of them. The answers are already posted on Edmodo. I'll do a couple of them. Number 6 or number 7? 6. Okay, so 6, it does not have an h or k. H is 0, k is 0. So you're not going to shift left or right. You're not going to go up or down. There is no h or k shift. So even if there were an h and k shift, you would ignore it and you would jump to your xy table. And when you plug in numbers that are in consecutive order, like -3, -2, -1, 0, 1, 2, and 3. Consecutive order. Now, why do you want consecutive order? That way you could plug in only one number and then work out the other outputs based on your growth or decay, based on your base. So if we look at the number 0, if I plug in a 0 right in here, it's 3 to the 0, which is 1, but with a negative in front, that will be -1 when you put in the 0. Now from this point, you could plug in 1 up here, work it out. You could plug in 2, work it out, and get those answers. Or you could just recognize that the base is 3, which means that that's a growth function, which means that it's going to grow by 3. It's going to grow by 3. So if I'm at the output -1 and it's going to grow by 3, I'm simply going to multiply it by 3, and that'll give me -3. If I want it to grow by 3, I multiply it by 3 again, it'll give me -9. -9. If I want it to grow again by 3, I multiply it by 3 and I get -27, which is already off the graph, so I don't need to worry about it. So if it's growing by the base 3, if it's growing by multiplying by 3 backwards, it's dividing by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. Or you could also think of it, dividing by 3 is the same thing as multiplying by 1/3. So if you think about it, 27 times 1/3 is 27/3, which reduces down to 9. 9 times 1/3 is 9/3, which reduces down to 3. 3 times 1/3 is 3/3, which reduces down to 1. 1 times 1/3, or -1 times 1/3, that's -1/3. And 1/3 times 1/3, that's -1/9. And times 1/3 is -1/27. So you get all of your inputs and outputs quickly just by knowing how the base actually makes it grow or decay, right? Just by looking at the base and seeing how it grows or decays. Pregunta. So let's graph these coordinates. Let's start by graphing the easiest coordinate, 0, -1. So I want to go over here, and 0, -1 is right here. There's 0, -1. The next coordinate is 1, and negative 1, 2, 3, it's right here. And then the one after that is the coordinate 2, negative 9. So 2 on the x and negative 9 is way down here. Now let's go backwards. Let's go to negative 1. The coordinate up here, negative 1, negative 1/3. Negative 1 and negative 1/3, that's not even halfway down. It's 1/3 of the way down. It's hardly nothing. So as you could tell, the next one up is going to be negative 2, negative 1/9. It's even closer to 0. So you can't even draw it anymore. It looks like you're just drawing dots closer and closer to 0. It looks like you just draw dots right on the x-axis. But you know it never actually touches. It just infinitely approaches. So I want to draw it like if it's touching, but you should know that it never actually touches. It just infinitely approaches. So there's my graph. However, if it had an H and K shift, I would have to shift it according to H and K. So my graph right now, there is no H and K, so I know it looks like it's touching, and then it goes down like that. Now let's talk domain and range. The domain are your x values, and x is all real numbers. Because it does go to the left forever, and it does go to the right forever. Even though it looks like it's going down, it never goes straight down. It always continues to go this way forever. Okay? So it is all real numbers. Now the range, on the other hand, are your y values, and y has to be less than 0. You can't say less than or equal to. Remember, the y values are up here and down here. Positive y values, negative y values. This whole graph is down here in the negatives. Does it actually touch the y equals 0 line? It looks like it touches, but we know that it never actually touches. It just infinitely approaches. To number 8. Let's show you how quickly we could do number 8. Well, first identify h and k. H is what? No hay nada. 0, right? There is no value with the x. The k value is negative 4. Once you identify h and k, you could box in the remainder of the function with ignoring h and k, and then you could go to an xy table and plug in consecutive integer inputs, nice and in order. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now, if I plug in one of these, the easiest one to plug in would be 0. So if I take the input 0 and plug it in right here, it'll be 2 to the 0, which is 1, but the negative a value on the front will make it negative 1. Now at this point, you could just take the base, and the base is 2. So it's going to be growing by 2. So you're going to multiply by 2 and you're going to get negative 2. And you're going to multiply by 2 and get negative 4. Multiply by 2, you get negative 8. Now, of course, you could actually do it the old way where you plug in the 3 right in here and you get 2 to the third, which is 8, with the negative in the front is negative 8. So you can do it the old way if you want. I like using the base to find the pattern of growth. In this case, this is a growth function because the base is greater than 1. So that's why it grows by 2. It grows by 2. It grows by 2. 1 times 2 is 4 times 2 is 8. Backwards, it wouldn't be multiplying by 2. It would be dividing by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. Or you could think of it, instead of dividing by 2, you could think of it as multiplying by 1/2. So 8 times half is 4, times half is 2, times half is 1, times half is half, times half is 1/4, times half is 1/8. So let's graph these coordinates. 0, negative 1 is right there. 1, negative 2 is right there. 3, negative 8 is way down here. And then negative 1, negative half is right there, halfway, well, right there, halfway down. And then it gets closer and closer to 0, so it looks like it's touching. Even though it never actually touches, it just infinitely approaches. However, we're not going to draw this whole thing because you still need to do a k shift of negative 4 units, which means you're going to be going 4 units down. So I always like to start with my asymptote. It looks like it's infinitely approaching this value. Let me take this line and move it 4 down. So if I go 4 down, 1, 2, 3, 4, I end up right here. So here's my new asymptote. And then I want to take each of the other coordinates and move them 4 down. 1, 2, so I want to take this guy, move this one and move it 4 down. There it is, 4 down. There it is. And the last one, 4 down, you're going to be off the graph. So if you look at your blue line, it continues like that. And that's your graph. Let's jump to number 12. Quickly, let's identify h and k. H is -1, k is -2. Now let's ignore h and k. Let me zoom in on my function and ignore it. Box in the function without the h and k. And now I'm going to go for an xy table. And I'm going to plug in consecutive integer inputs. The numbers I plug in are going to be in order from least to greatest. So you really aren't going to plug in all these numbers. Just plug in one of them, like 0. 1/2 to the 0 power is 1. And 1 times 3 is 3. So when I plug in 0, I get out a 3. Agree? Now, at this point, I could plug in 1 and work it out, or I could plug in 2 and work it out, or I could say, wait a minute, this is a decay function because the base is less than 1. So that means that this output 3 is going to decay. It's going to get smaller. And how is this 3 going to get smaller? How is it going to decay? It's going to decay by 1/2. So in other words, 3 times 1/2, that's 3/2, which is really 1.5 when I start graphing. But I'm going to leave it as 3/2 right now. And then 3/2 times half, it's going to get smaller. 3/2 times half is going to be 3/4. 3/4. And then 3/4 times 1/2, again, that'll be what? 3/8. But as you could see, the next one will be 3/16, 3 over 32, 3 over 64, 3 over 128. And if you think about those fractions, if you were to divide them, they keep getting smaller and smaller, closer to 0. This one's 0.75. So the top one was 1.5, this one's 0.75. The next one, 3 divided by 8 on a calculator, is 0.375. 0.375, so it's even smaller. It keeps getting closer and closer to 0. So if going this way we're multiplying by half, going backwards we'd be multiplying, if going that way we're multiplying, if we're going that way we're multiplying by half, going backwards we'd have to multiply by the reciprocal of 1/2, which is multiplying by 2. Okay? So right here, from here to here, we multiplied by half, so we're going to be multiplying by 2. So 1.5 times 2 is 3. The next one would be times 2, that would be 6. And then times 2 is 12, times 2 is 24. And you're not going to use those because it's only a 10 by 10 graph. So let's graph what we have right now. So far I put the 0, 3 right here, I put the -1, 6 right there, I put the -2, 12, which is already off the graph, so I'm not going to do -3, 24. Let me plug in the 1, 1.5, and let me zoom in a little here. So you can go 1, 1.5. There it is, 1 on the x, 1.5 on the y, halfway up to 2 from 1. And then the next one's going to be 2 and 0.75. So 2 and 0.75, it's not even 1. It's 0.75, it's less than 1. And the next one, 3 and 0.3, that's even less than half. It's super close to 0. So as you can see, it looks like it's going to be touching, it's ugly, it looks like it's going to be touching the x-axis. But we know it never actually touches, just infinitely approaches. The other thing is you have to modify the coordinates according to h and k. So move all of your coordinates 1 unit to the left, 2 units down. Now you see how it looks like it actually touches the x? I might as well move that down 2 units so I could get a better place of where my graph is going to end up. There, it's going to end up there. Now the other coordinates, I'm going to move 1 to the left and 2 down. So there it is, this one that was off the graph, 1 to the left, 2 down, 1 to the left, 2 down, 2 down, 1 to the left, 2 down, and so on and so on. So here's my final graph, these blue dots. And the red one, if for some reason you drew the red one, that's okay. Just make sure you do this. Put 2 X's on it so when I grade your papers, I know that the red one's not the graph you want to show me. It's the blue one. So that's about it. All the other things that you could say is that the domain is x equals all real numbers and the range is greater than -2.